So use substitutions comes into play whenever we cannot formally take our integral, right? So anytime you're kind of stuck on an integral, you can't really integrate using your just basic addition or subtraction. This is where u substitution comes into play. So with u substitution, what you want to do is that you want to let u equal some value that when you take that derivative, you already have it there, right? And what do I mean by it? We could change constants. We could change constant. We can change our derivative, and we can change our x's, right? So in this case, what will be my u? Well, looking at this, I'll make my u be equal to 4x to the fourth minus 3. And the reason being is that once I take that derivative, I will have an x cubed, which is here. Now, I won't have one x cubed. I'll have some number of x cubed, but we don't care about that. We could change fraction. We could change numbers. We just can't change our x's, right? So in this case, our u will be 4x to the fourth minus 3. And now all we do is take our derivative. So du will just be 4 times 4 is 16x cubed dx, right? That will be your derivative. Well, we just said that we have 1x cubed and not 16x cubed, but that's okay. We could get rid of the 16 by dividing by 16 on both sides. And 1/16 du will just be x cubed dx, which is exactly what we have. So now we can just plug it in. All right. So setting up a new integral. I always kind of put my constants, right, out on the front, but it doesn't matter. You could put it inside. I just usually put it out front. And 1/16 du, right, will take rid of this x cubed dx, right? This will substitute for this x cubed dx here, right? Notice we don't have anything on the top, and that will just be 1 over u, right? That is just 1 over u. And you got to remember now, that is just 1 over u, but this is raised to the 12th power. All right. Immediately I see something I could do. I could set this up in a sense where I have 1/16 of u to the negative 12 du, right? All I did was just flip my u in the denominator and add a negative to that sign here. So now I could go ahead and take my integral. So my integral would just be 1/16. And we just use a rule. We just add 1 and divide by that same number that we get. So this will just be u to the negative 11 divided by negative 11 plus c, because it's indefinite. So we got to add that plus c, right? And so I could just multiply this 1 over negative 1 over 11, and that will just give me 1 over 176. And that's just a minus because we have this minus here. And that will just be u equal to the negative 11 plus c. And then all we do is plug in our u from here. All right. So our answer will formally be negative 1 over 76 multiplied by 4x to the fourth minus 3 to the negative 11 plus c. And that will be your integral. Let's look at another one. How about this one? E to the x minus, how about this? It looks complicated, right? Here's a trick, guys. Well, not a trick, but here's the first thing you want to do. And these problems are kind of like a trial and error. All right, set your u. The first thing you want to try is your denominator. You want to set your u to some value that's in the denominator. And the reason being is that you might possibly come out with what's on the numerator. You don't want to use your numerator at times because at times you'll get 1 over the denominator, and that is not what you have. So in this case, I'm gonna let u is equal to e to the x minus e to the negative x. Taking the derivative of this, well, the derivative of e to the x is e to the x minus, using the chain rule, the derivative of e to the negative x is just negative e to the negative x dx. Simplifying that, du is just going to equal e to the x plus e to the negative x dx. All right, and this is exactly what we have here, right? So in this case, we got lucky. So the integral, we could rewrite that, will just be 1 over u du. Du takes takes care of this whole e to the x plus e to the negative x here. All right, so that will just be, that becomes 1 because that 1 du, and you could even write as du over u, and this was your u, right? Now anytime you see 1 over u, that will always give you the natural log. So the integral of this will just be the natural log of the absolute value of u plus c, right? And then all we could do is just plug in our u, which is e to the x plus e to the negative x plus c, and that will be your answer. So it certainly looks complicated, but again, it's not anything that's too complicated, right? Let's look at this one. E to the secant x, secant of x, tangent of x, all right? What would I set my u's equal to? Well, again, you want to look for things in terms of trigonometric functions, look for things that are derivative of each other. So what do I mean by that? When you take the derivative of that u, you should always get something that's already there. So this is what I mean. I'm gonna let u equal my secant of x, right? So u is equal to secant of x, right? My derivative of u is secant of x, tangent of x, dx. And look, this is exactly what I have. So this is what I mean, you guys. Look for things in terms of trigonometric functions. Look for things that are actually derivatives of each other. So now that my du will represent this whole thing here. So my new integral will just be 4 times e to the u, because secant of x is what we use for u, du, right? This du took care of this whole secant of x tangent of x dx thing, right? And now we could just go ahead and take our integral, right? Well, the derivative, well, the integral of 4e to the u is just 4e to the u plus c. And then we could just plug in our u, which is 4e secant of x plus c. And that will be our integral. Let's look at one more. 2 of x to the 4th e to the x to the 5th. All right, again, I'm going to set my u to x to the 5th. And the reason being is that when I take the derivative, I'm going to have some value of, I'm going to have x to the 4th with some constant, which I don't care about. We could fix constants, right? So in this case, my u is going to be equal to x to the 5th. Du of that is just 5 x to the 4th dx, right? We have a 5x to the 4th and we have a 1x to the 4th. We could fix a 5 by dividing on both sides, right? So 1/5 du is equal to x to the 4th dx. And all I did was just factor out this 1/5 from the du and multiply it. It's the same thing. All right. So 1/5 du will totally replace this. All right. So my new integral would just be 2. And you can multiply your 1/5 on, because I'm going to always put my constants on both on the outside. So this is 2 times 1/5. Du takes care of x to the 4th, right? So this is really just e to the u du, all right? This stays the same, e to the u, or du, 1/5 du took care of x to the 4th dx, right? And we have our 2 on the outside. So in this case, we're ready to take our integral. So I'm just fix this up a little bit, and this will be 2/5, but the integral from e to the u du. Well, again, the antiderivative of e to the u is just e to the u, right? So this will be 2/5 e to the u plus c, right? And then we just plug in our u, where this will be 2/5 e to the x to the 5th plus c, and this will be our integral.